Okay, we're messing with transistors today. I'm going to explain how we have it all wired up, and then you can see me turn it on and off. So here's a PNP style transistor that we have here. I just soldered some leads onto it so you can see that. And what we have is we have the higher current test light hooked up to the collector. And the collector will flow current through the emitter. Once the base is grounded or pulled low, that'll open this gate. And so once current is allowed to flow this direction, that'll open this gate, and then current will flow that way through this side. This other test light is a much lower current test light, so this is about 250 milliamps at 12 volts. This one's about 50 at 12 volts. And so I think we're running right around 6 volts on the power supply. So our power feed's coming in here to the emitter side of the transistor. And then once we allow current to flow through the base, that'll open the gate here and allow current to flow this way to our load, or our 250 milliamp light. Now I have this switched so we can see our voltage. So we measure here, and you can see we have 6 volts. And if I measure over here at the base, we have 5.4. And if I measure here, we have 0. So now what I want to do is connect. Now this test light is ran to ground, so this is on the positive side of that test light. I'm going to pull this voltage, or allow current to flow through the base, and you can see there's current flowing on the meter now, or on the power supply. You see our little lights lit up a little bit. I don't know if you can see it, just a little, and that one's lit up. So now we know, because our light's lit up, that we have voltage here. So now we have voltage on this side. And when we remove current flow from the base, our gate closes, and now we have 0 voltage here. So that's how that works, is the current flows from the emitter to the base. That opens the gate and allows current to flow through this transistor, through here, through that to ground, lighting our load. So it works kind of like a relay, except these are much faster, much more reliable. And since they take such a small amount of current flow across the emitter and base to turn them on and off, see, there's only maybe 20 milliamps flowing through that little light. And that is enough to turn this switch on and turn our load on. That's how something like this little itty bitty circuit board and that little controller can control major power circuits through transistors like that. So I'll show this again. This is what it looks like on a data sheet. That's what it looks like in a diagram. And when there's current not flowing from in the emitter and out the base, this gate is closed and there's no current flowing out of the collector. When we do have current flowing through the emitter out the base, that opens this gate and allows current to flow out of the collector and to our load. I was just playing around doing some soldering and stuff. Had to take one off anyway for practice, so I figured we might as well test it. This isn't a great way to test it because we soldered leads onto it, but you know, if we were careful, we could test this using current limiting resistors or specific light bulbs and determine whether we have a failed component or not. So I know this component is good, and it switches really fast. So just want to give you an example of how fast they can switch. You know, I can't even do it as fast as a computer can switch it. It's incredible. So yeah, that is the ticket to the modern world. If it wasn't for transistors, computers wouldn't even really be a thing. So it's pretty cool. I hope this all makes sense to you. That is how computers control loads. Pretty much all automotive computers have some transistors. And like I said, most transistors are used to control loads and input-output devices, but they really are, aside from the processor and the memory, these are the hands of the computer. These are what really allow computers to control all sorts of things, where on older vehicles you would see bunches of relays mounted all over the place. Now we have body control modules with tons of these inside, and it's a huge weight savings, obviously. I mean, that's smaller than my pinky, and it can control a pretty heavy load. I think the data sheet said this could handle 30 amps. I'm not going to take the time to set up a real high current load on this, but either way, it'll probably get a little warm on 30 amps. That's why they put the collector on the base here. Well, I don't want to confuse you. The collector on the bottom, and it's such a big footprint, is because that's going to be carrying the major part of the current, and that also helps dissipate heat away from the switch, which is silicon in here, and that's what makes everything work. So there's the gate closing again. All you got to do is remove current flow, gate closes, add current flow, gate opens. So real straightforward. Hope that makes sense. There are a whole lot of different transistors. That's why data sheets matter. There's a whole lot of specs that goes along with this, like current and voltage thresholds to make them come on and off. There's probably just hundreds and hundreds of different size and options and packages, but this is the basics of a PNP resistor, or a PNP transistor, is how that functions. So I hope that makes sense. Thanks for watching. I hope this helps with your understanding of how computers work, and this is typically what fails when people say we lost a driver. They'll use these to drive injectors, ignition coils, all kinds of things, evap solenoids. Some of the older Dodges, the charging system would fail. The regulator inside the PCM was really just one of these, and it would overload and fail. And when they fail, usually it's catastrophic. These will get stupid hot and burn a hole right through the board sometimes. But I just had some time today, wanted to kind of show you how those work. So I hope that helps make sense. So the voltage matters, depending on the transistor you're using, but more importantly, you want to make sure it can handle the current flow and the voltage you're putting at it. That's why I just set it up for 6 volts, because I wasn't going to study the data sheet for an hour to demonstrate this, but 6 volts with this low of current isn't going to damage anything. And you can see it carries the load just fine. Current flows from the emitter through to the base to turn the gate on, and I could see that visually with both lights. I could see it flow out of the collector through ground through that light. So we know this transistor is functioning as designed. So thanks for watching. If you like this, like, share, comment. If you want to see more or different examples of different things, comment, ask, and I'll do my best to deliver.